Hello guys, today we will discuss one more problem based on backtracking, that is 01 knapsack problem. We will see one example. The question is, we have given 4 weights with their corresponding profits. We have to fill the knapsack of capacity 8 using these weights such that knapsack is filled with maximum profit. So let's see how the backtracking can be used to solve this particular problem. As we know that backtracking generates the solution space tree in DFS manner. Then we'll see how we'll kill some of the nodes by applying criteria, or you can say some bounding function. Let's see this example and we'll see how to solve this using backtracking. We have given these 4 weights with their corresponding profit. This problem can be solved using greedy approach, using dynamic approach. We'll apply backtracking and see how we'll solve the backtracking. Initially we have considered no weight, that's why we have no profit. You can consider it like W comma P vector. Okay. So we'll explore. We'll consider the first weight. And when we consider first weight, the weight value will be 2 and how much profit we have earned will be 3. As backtracking explore the solution space tree in DFS manner, so we will move further and after considering 1, we will see the second weight. We will consider the second one. Can we consider this or not? As capacity is 8, we have only reached to the 2, we can take this particular weight. Okay. So, if we next weight, the total weight become 5 and the profit will become 8. Still, we are satisfying the constraint. Now, we will consider the third weight. After considering 1, 2, we will consider the third weight. The weight value is 4. So now, the total weight becomes 9 and the total profit becomes 14. You will see the capacity is 8. So, we exceed the capacity. So we will backtrack to the previous one and see, after taking second weight, we can't take third one. So after rejecting third, in DFS manner, we can go for the another option, that is the fourth weight. So it will be like 10, 18. Again, we have exceeded the capacity, so we will not consider this. This was like this. So we discard this. Now we have considered all and we have not reached to the final capacity, that is 8. So we will discard this one also. Here you can see, this is the important one. Backtracking is not used for optimization. Backtracking is used for generating all possibilities. We might have not get the solution where the knapsack will fill with its complete capacity. Backtracking will not help us in those kinds of conditions because it is never used for optimization by the problem. This is one of the things that we must get in mind. If there is a combination exists where knapsack can fill completely, then by backtracking we can get that. If not, backtracking will not give us the optimal solution. This is one of the important points. Where branch and bound help us to get the optimization values. Okay, we will continue this. We will reach to the, now after discarding 3, after discarding 4, after discarding 3, we will reach to this node. Here we have considered the second weight. Now we will discard the second weight. So we will have the same values. Now consider the third weight. When we consider the third weight, the weight value will be the 6, 4 plus 2 6 and 3 plus 6 will be 9. Still we have a space as the capacity is 8. So we will consider the fourth one. When we consider the fourth one, now weight value is 11 and the profit value is 19. Again we have exceeded the capacity, we will not consider this. Now we will not consider this. Again we will not reach to the capacity and no more weight is left. So this is also another counter solution. So after not considering 4, we will reach to consider 3. Now backtrack to the previous node. So after rejecting 2, again we will discard in 3. So we will have the same values. Now considering 1, not considering 2, not considering 3, we will consider 4th. So 4th weight value is 5, it is 7 and profit value is 13. As no more left, weight is left, we will not reach to the maximum, that 8, so we will not consider this. And again, if we discard this, we will reach this to this. Again, it is far less than the total capacity. So we have seen that up till now we have not get any solution. We will backtrack to not considering 4, not consider 3. All these after considering 1. So no more tree is left to explore. So we'll go for another possibility, and now we are not considering. I have to take this solution over here, and this is something space problem over here. No, we have not considering possibility. So you can see we'll have 0 weight and 0 profit. So now after discarding first, we'll consider the second weight. When we consider the second weight, the situation will be like, you can see weight value is 3 and profit value is 5. So after considering second weight, we will consider third weight. When we consider third weight, the situation is like, third weight is 4, 7, 11. Again, the capacity is left, so we will consider the fourth one. When we consider the fourth one, the weight value is 12 and profit value is 21. We need to discard this as we exceed to the capacity. If we will not consider fourth one, it will remain 7, 11. No more weight left, so it will not give us the solution. So discarding 4, we will reach here. We have considered 3. Now we will generate one more option. We will not consider 3. Now we consider 4th. Not considering 3, when we consider 4, not considering 3, when we consider 4th, the weight value is 8 and the profit value is 15. So you can see this will be one of the solutions. So we have seen how the backtracking can be used to solve 0 and knapsack problem. But if we just change these questions, we can see here the only one solution. We can see the combination of 3 plus 5 giving us 8. There is no other solution exists. If suppose no combination is giving value 8, so backtracking will fail us to give the solution for this particular problem. This might be the case. Even we will consider the backtracking problem, we will consider the 0, 1 knapsack or even some subset problem. This might be possible. There is no combination exists which gives us that particular value. In these kind of thing, where some optimization value is required or approximate value is required, here the backtracking fails to give a solution. That's why the branch and bound is applied to such type of problem to give the optimal values. Thank you.